Hello and welcome to Domzoller for this new training session. Today we are going to talk about the NPA 345. I am Stefan Arouet and I work in the design office. During this presentation we will discuss the mounting plates because the NPA 345 is only installed on trapezoidal sheet metal and it is fastened using stitching screws here. We will also talk about grounding the system and of course its various module fastenings. The NPA 345 system is certified with an ETN for new technical solutions, so it is installed on trapezoidal sheet metal and only in landscape mode. I encourage you to look at the installation manual as well as the ETN certification because you will see that it can be installed with a purlin spacing of up to 2 meters for 0.75 millimeter sheet metal and 1.80 meters for 0.63 millimeter sheet metal. Of course, to ensure this system holds, we will carry out a structural calculation report. So just because it says 2 meters purlin spacing doesn't mean you'll be able to use that spacing on your project. We will definitely keep you informed to let you know whether or not it is possible. We can do it, and it's the results of the structural calculation report that will give us all this information. The profile of the sheet is only for the 3.45 type, meaning 3 corrugations and a wave height of 45 millimeters with a trapezoidal profile. Before doing the final layout and going up on the roof to install the system, you will have sent us the preliminary plans for your layout, the structural plans. We need as much information as possible about your roof so that we can carry out the calculation report and see if your system can be installed and supported on your roof. Don't hesitate to send us the technical data sheet for the sheet metal, the technical data sheet for the module, and your layout plan. Be careful because with NPA 345, you will be putting yourself only in the sheet metal. So at the ridge, if there is a cover plate or if there are lifelines, you really need to be careful. That means leaving a margin of about 35 centimeters so as not to place it at the ridge. The NPA 345 and its plates are installed outside the purlin screws, so you'll also need to check this once you're on the roof. With the spacing and measurements we've provided, so as not to end up on those well-known fasteners that attach the sheet to the purlin. For this particular project, we are pleased to provide you with a comprehensive and final layout plan. This detailed plan includes a complete list of all the necessary parts and components, precise roof measurements, and the critical cumulative measurements specifically calculated for the very first rail column. So be very careful right from the start. Make sure to use the measurements we've given you, meaning that from rail to rail, it's really from one end of the base plate to the other end of the base plate. Check if it fits properly on your roof. For example, here it's 17.26 meters. And then we give you this zero measurement bottom of the base plate, and it's always from the bottom of the base plate that the cumulative measurements are indicated. We will also look at grounding the system. When you get to on the roof, you will need to carefully check a few important things. The size of the roof from edge to edge, the locations of the base plates where your module fasteners will go. And for that, we will create 2 gauges. Module height dimensions plus the gap between modules. There you go, here. I've made a gauge where you can see the length of the module up to this mark here, which represents the gap you'll leave between modules. By default, at Domzoller, we leave 9 millimeters between the columns of modules. If you want more, it's best to let us know beforehand so that we can do the layout with the correct spacing. The gauge between edge of the module is 13 centimeters, no mounting. Between the edge of the module and from 13 centimeters plus 33, so between 13 and 46 centimeters from the edge of the module, it's possible to install a mounting bracket and therefore a plate. For example, here I have a representation of a tray. We're going to install our first rail. If, for example, the roof goes from right to left, we install the bracket. We come here and check where our brackets will fall in relation to the corrugations. And we much prefer to work with two skilled technicians so that both measuring gauges can be carefully placed end to end. That way, you can accurately mark your precise spacing between the individual modules as well as the sturdy brackets on each prominent crest of the tray's corrugation. You could be, for example, in a case like this. Generally, since you're working with a 333 tray, your brackets under the module are spaced 1 meter apart. And then what can sometimes happen quite unexpectedly is that your knitting gauge, the very fabric density you are creating, actually, if I were to demonstrate and show it clearly on the screen for everyone to see, like this, you'll have a 333 centimeter mark that falls between two corrugations. You'll be thinking, shoot, which corrugation should I use? Actually, it's the other mark on your gauge that you'll look at, because that one will be lined up exactly with the corrugation peak. So you'll make your mark based on that corrugation peak and always at least 1 meter apart. So you could very well start again here. So I know there are other techniques like cumulative codes where you stretch out your 20 meters, 30 meters, 50 meters, and you make your module marks. That works really, really well. There are quite a few teams that do it that way. And then you'll see where your waves actually fall in relation to the modules, to the sides of the modules, knowing that most module manufacturers, thank you, these are mounting zones along the length of the module. It's actually the length of the module divided by 4 plus or minus 50. Generally, it's around 45 centimeters. There are other manufacturers who will give you mounting zones between 0 and 50 centimeters. You can also check the mounting zones specified by the module manufacturer. The module manufacturer has never created their mounting zones based on the 333 tray or any other tray. It's based on these effects. Get spray paint cans in different colors so you can mark the wave crests of the tray as well as the markers between the modules. Number your module columns carefully. This will greatly help you with your overall layout, precisely placing your modules, effectively finding your way on the roof, and also efficiently setting up your strings. This particular plate is made with 3 holes on each side on these fins, which allow you to attach it to the sides of the wave crest of the tray with 3 self-drilling screws. These come from Itanco. They're 6-3 by Vamu. There is one precisely positioned in the very center of the entire plate, and then 2 additional ones are carefully placed at the extreme ends of the distinct holes located on the other extended fin of the robust plate. Here you can see it a bit better. In general, the primary technician will first carefully attach it securely in the precise middle of the plate, and then, subsequently, another skilled technician will come to diligently secure the other 2 remaining sections at the ends of the fins of the plate. This prevents the same technician from having to go to the left side and then the right side. For this, you can use the 3-4-5 method, meaning that in any case, your plates will follow the waves of the tray in the direction of the slope. Or if you're used to it, I know that quite a few technicians will just pull a chalk line directly from edge to edge and say, there, we're good, we're straight. And on the other hand, don't forget to check this measurement from rail to rail to avoid getting stuck right at the flashing sheet at the ridge. Otherwise, there's the 3-4-5 method. You've made your 0 mark. You know that's where your first plate will be installed. And then you can mark a reference point at 3 meters from an edge of the tray or along the axis of the wave crest of the tray, a mark at 3 meters. Next, draw an arc from point 0 at 4 meters. So either you'll be at the wave crest or you'll be on the flat part of the tray. That's why you need to make a small arc. Your reference at 5 meters, that is between the 3 meter point and the 4 meter point, you should have 5 meters. And then you can stretch your chalk line over 15 meters. Don't try. If you have a generator that spans 15 meters, for example, from the left bank to the right bank, that's fine. You can do it all at once. But if your roof is already more than 30 meters and a generator is more than 30 meters, you'll have to do it several times because with a chalk line over 30 meters, you'll never get it straight. So now you've snapped your chalk line, you've made your 3, 4, 5 mark, and on top of that, you have your wave crest markers that were previously made with the plumb bob. Now you'll be able to install the first base plate. And the base plate goes either at the center head of the generator or at the end of the generator. If you have a 15-meter generator, if you have a 30-meter generator, of course, you'll do the first, the middle, and the end. And if you have more, you'll obviously have to repeat the process several times, and even your 3, 4, 5 measurement will have to be done in several places. And once you've installed your first 2 base plates at the bottom, all you have to do is place all the base plates along the bottom of the generator. We always start from the bottom. With the NPA 345 system, you begin at the bottom. Then you can install the first row, the first column of base plates, the last column of base plates, and proceed using the cumulative measurements and your tape measure. And make your marks for the cumulative measurements. And so on. Place your base plate, your 2 end plates, then move toward the center. With all your base plates, according to the marks you've made at the crest of the wave, and so on, all the way up to the top of the roof. Be careful. With the NPA 345 base plate, you cannot place it where the tray is attached to the purlin. So before making your markings, before making your reference points, as we did earlier, you also need to check where you end up. So you might need to shift the generator a bit, but be careful not to end up on that purlin screw. No base plate should be on a tray to purlin attachment. The rail alignments must, of course, be done with a chalk line. You are on the slope with a 10mm gap between the modules. To fasten the base plates, use 3 6.3 by 22 screws and tighten the base plates to 3 Newton meters. And of course, if your project is less than 3 kilometers from the sea, we will provide you with AK screws. Just for your information, we are currently developing a new base plate that will go over the purlin attachments. For now, it's still under review, and we will provide you with new training and notify you very soon so that you can get the new base plates, which will be a big advantage for you. That means you will have been able to check the tray fastenings at the purlin level. The grounding of the NPA 345 can be accomplished in 2 distinct ways. Either you meticulously ground the very first and the very last rows of modules with the CTM, or alternatively with an equivalent and suitable part. Here, we are specifically referring to a small, compact module. The CTM is securely connected here to the electrical ground using a specially designed pointed screw that will effectively strip the insulation from the robust 6 square millimeter green-yellow wire. Be careful with the tightening. The torque should be between 2.5 and 3 newtons. Especially when tightening, do not go all the way against the aluminum here on the CTM because you will make contact with the copper wire and the aluminum, which do not go well together. Once you have prepared your CTM with the green-yellow wire, you slide it under the frame of the module here, for example. And you tighten it to 3 newtons, also between 2.5 and 3 newtons, using a 3mm Allen key. The second method is to ground the steel tray. We will also reuse the CTM or an equivalent part, but you can also download from our website the certification we obtained from the LCE Veritas office, which guarantees this test. So you will, this time, position the CTM at the level of the steel tray. Tighten it again using the 3mm Allen key to 4 newtons. As for the position of the CTM, generally we place it under the ridge flashing sheet. Otherwise, put it in a spot that's not very visible, especially where there's water. And then once it's installed, it's up to you to carefully check your essential equipotential bonding between the tray and the NPA 345 base plate, ensuring a secure and reliable connection. And once you have grounded your tray, either you do it with the modules or with the tray itself, and of course we move on to installing the modules. always start at the bottom of the generator, so the first row at the bottom of the roof. The intermodule fastener is what will make the connection between the model frames. By tightening it, it slides right into the groove here when you install the modules. The external fastener, you'll have it at the top and bottom of the generator as well, using the same type of T-nut that you slide in when installing the module. Of course, you will always start your module in the middle of the plate, knowing that your screw here gives you a 10 millimeter gap between each module. So your plate is 10 centimeters and your module is about 4.5 millimeters from the edge of the plate. I'll try to show this as clearly as possible. Here, and there. We are observing the external fastener here, which is a critical component. This fastener is specifically designed for the intermodule connection. There's actually a small tiny claw on the clamp, which will allow you to have equipotential continuity. Use a 6 millimeter Allen key, tightening torque 6 Newton meters. We've reached the end of this presentation of the NPA 345. Feel free to visit our website to download the installation manual. Because the video is great, but there's also the installation manual. You can also download the ETN, the certification. Don't hesitate to check if your module also matches the ETN. For example, we have a little search engine where you can enter the manufacturer, let's say, for example, Longi. It will show you a reference. And it will clearly tell you with which specific system your current system is officially validated. Here, for example, with the NPA, but you also have all the other systems. So already this can tell you, it can already give you information about the module and the certification. There you go, we've reached the end of this presentation. After watching this, you can get a certificate by answering a short questionnaire. And if you have any questions, feel free to email me. Here is the address on the slide. And if it's regarding your project, please make sure to specify the file number starting with F or E, the name of your project, and of course the system. Specify which system you are on. In any case, all that's left for me is to wish you a great day and a good start to your construction project. Thank you. Have a nice day. Goodbye.